Hello everybody, so in this video we are going to look at Bitcoin and we're going to solve an example question from Programming Bitcoin, the book by Jimmy Song. So without further ado, let's just have a little recap on why Bitcoin is so significant, and we'll get to the question and write some code shortly. So firstly, to coin a lyric from one of my favorite bands, I used to think that Bitcoin was for punks and cannonballers. um, Obviously, it started off with the cypherpunk movement, and yeah, moved on from there. So we are where we are. And as of today, I've just had a letter from my bank telling me that the cost of my monthly payments on my house are going up by a significant amount. We're being predicted to have double the cost of fuel for gas or electric by the end of the year, if not more. So why is this happening? And if you don't follow the financial news or whatever, let me just quickly summarize. Over the past decade or so, or since the global financial crisis, which happened in 2008, 2009, there's this thing called quantitative easing, where lots and lots of money is printed by the central bank, and they use it to buy government-issued bonds. So the government gets a good deal because they can sell these bonds, which are basically a promise to repay certain amount of money back to the bank each month, which gives the bank a nice guaranteed income and a return on their money. But the bank can issue this money out of thin air, and yeah, I know, it sounds amazing. Once you know this, you can't unknow it. And if you want to read more about inflation, and obviously you can find it yourself, but one tip is learn about Austrian economics. And yeah, their argument is that you can't centrally plan an economy, which is what the modern world is trying to do. That's not a, we've got the European Central Bank, you've got the Federal Reserve, you've got the Bank of England. They all have meetings, they all consult, and they all try and kind of match. Well, the problem is they all try and get something for nothing for their own people. And the Federal Reserve, which was formed in, I think it was in 1911, many would argue has had a very detrimental effect on the world. And well, I won't give you my personal opinion, but yeah, you know where I'm coming from. So Bitcoin is hope. Michael Saylor, who personally I think is a legend, he even bought up loads of domain names in the late 90s because he thought it would be speculative good investment, and how right that's proven. But yeah, hope.com, and you can read all about Bitcoin. So no point me trying to do it here because I'm not an expert on the subject, but I know enough about it now to point you in the right direction, so shall we say. So this is actually Bitcoin for corporations, so it's trying to explain why you can hold it on your balance sheet, why it's digital property. And I've not watched all of these, but hopefully I'm guessing it explains the difference between Bitcoin and crypto in quotes, because crypto is, well, as you know, NFTs, crypto heads, Bored Ape Yacht Club, or whatever the hell that is. So yeah, if that's your thing, then yeah, good luck. But what we're looking at here is this is quite a famous graph, and I just want to talk about this for a second. So this chart, let me just zoom in on it if you can. No, the chart doesn't get bigger, that's a shame. Anyway, you can see the two lines. You've got a green line and a blue line. Now, the green line, which is the longer line, is is the total internet users in millions, and the blue line, which is almost tracking that, but there's a there's a lag on it, and it's showing what happened between. Okay, yeah. So the green line is showing what happened between 1990 and 2000. So during that decade, probably some of you weren't even born then. I was, as you can probably guess. But what happened was internet adoption rocketed, and it climbed very rapidly. Now you can superimpose this virtually almost the same gradient. Obviously, the gradient is the rate of adoption, and the blue line is total crypto users in millions. I'm guessing probably it's Zoomers rather than Boomers. Although I think there's some pretty switched on Boomers and out there who are people like Ray Dalio and I don't know I don't know what their names, but there's some pretty experienced Boomers out there who are also buying Bitcoin in the world of investment. You may also hear it called fiat. Fiat, which is the same as the name of the car. Obviously, Fiat is an Italian car manufacturer, and Fiat is a Latin word, so probably there's some link up there. But Fiat in Latin actually means by decree, which kind of means because we say so. So that's why we all have to pay taxes in, if you're in America, in dollars, if you're in UK, in pounds. If you're in Europe, then in euros. So you can only pay your taxes in. You can't pay your taxes to the government in gold bars. You used to be able to, or you used to be able to exchange gold for dollars, but you can't do that, not unless you're a global government and so on. Look up 15th of August 1971. It was called the closing of the gold window. What happened in 1971 has basically changed the world. If you don't subscribe to that, then be interested to hear. But yeah, it's changed everything. Rumor has it that America did that because of what's called the exorbitant privilege. After the Second World War, there was a thing called the Bretton Woods Conference, which is where it was decided that all the countries of the world would peg their currencies to the dollar, and the dollar, for stability, would be pegged to gold. But yeah, that's all long since unravelled, and now we're in what I would say the mess we're in. Right, so yeah, back in early 2020, on-chain analyst Willy Woo, quite a famous Bitcoin analyst, commented that crypto adoption is comparable to that of the internet. So basically, what happened in the 90s with the internet is now happening since 2014 with crypto adoption. So there's always kind of this. Sometimes you'll read about crypto, sometimes you read about Bitcoin, and obviously Bitcoin is kind of a crypto, but not all cryptos are Bitcoin, if that makes sense. Anyway, so let's just read this, and then we'll get on with some code. So Wu said, mass crypto adoption isn't here yet, nor do the masses see it happening because human perception tends to process information linearly. Human nature is one that looks at things in a linear stance, so we're not very good at looking at exponential growth, which is obviously what Bitcoin is doing. Current estimates on the number of crypto users vary. While Davies puts the figure at 200 million, about 2.5% of the global population, research conducted by blockchain solutions firm AAA puts the number of users at 300 million, or just under 4% of the worldwide population. This was written quite a while ago, I think it's last year, wasn't it? So you can add on a bit for that now. Yeah, Web 3.0. Yeah, not even going to talk about that because that's a kind of a red herring as far as we're concerned. But right, so that's kind of all the glamorous bits and the shock horror and the bits that probably would appeal to, yeah, the emotional side of our brains. And any kind of dramatic news appeals, as we know, appeals to the emotional side. Let's now appeal to the logical side of our brain, which is solving this problem. Now, this problem is from I think it's chapter 2 of the book, which is called Programming Bitcoin. I'm trying to find you the front cover. I don't know how to do that. Let's go back. There we go. And that's a honey badger. So enough about the honey badger, and this is the book. So if you're interested, I'm picking out a few examples from this book by Jimmy Song. I'm not, in fairness, hopefully anyone who sees this realizes I'm kind of hoping to promote the book rather than plagiarize it. So there's hundreds of pages, so I'm not really going to stop anybody from buying it. If you watch these videos, hopefully you'll watch them and think, oh, I'll buy that book. Okay, so this is from exercise 5. 4k equals 1, 3, 7, 13, 18. What is this set in F19? So F is a finite element set. And if you saw the previous video, you'll know that these sets, from the perspective of Bitcoin and these examples, are always a prime number. So 19 is a prime number. If you don't know what prime number is, it's a number that's only divisible by itself. So 19, for instance, is only divisible by 1 or by 19. So in the curly braces, what it's saying is, okay, the full stop, or the black dot, looks like a bullet point. Whilst we're doing these examples, the black dot means multiply. I don't know why it's not the asterisk. I guess because this is based on mathematics, kind of academic mathematics. So, yeah, perhaps they don't. X is typically used as, yeah, a variable name, isn't it? So anyway, what we're doing is we're going to say 1 times 0, 1 times 1, 1 times 2, 1 times 3, all the way up to 1 times 18. Then, so that's going to be, we'll produce the output once for 1. Then we'll do the same for 3. So it'll be 3. So where k is 3, it'll be 3 times 0, 3 times 1, 3 times 2, 3 times 3, 3, all the way up to 3 times 18. Where k is 13, it'll be 13 times 0, 13 times 1, so on, and then 18. So we're going to have 5 lists here. So already you can almost imagine the Python syntax. Difficult bit is then doing the modulo, because let's just get on with it. So prime is 19 because it's 19 here. That tells us what the size of this set is, and that's the prime number we need to be using. So yeah, refer to the previous video if this is not making sense yet. So really what we're going to be doing is we're going to be making 5 lists and using modulus 19. So let's say 4k. No, for iterator, so we'll say for I in k. Okay. Let's just we'll test everything's working to start with before we get too far and then find out something's broken. So there we go. We've got a loop that runs 5 times, as we would expect. So on the first iteration, we'll be using 1s, then we'll be using 3s, then 7s, then 13s, then 18s. So the way to solve this is we're actually going to use we use list comprehension inside of a for loop. So the list comprehension is going to be a for loop, which will generate kind of a horizontal list, and then the k will create our vertical. So what we're going to be saying is so we need to do 19 of these. So we're going to be going horizontally 19. We need to go from 0 up to. So then we'll say for n in range 0, 19. So that's going to tell us to do something 19 times, which will then we need to say n times yeah, I times n, and then we need, so let's put the I times n, let's put that in brackets, parentheses, and then we do sorry, I did a / there. I meant to do a percentage. There we go. Modulo 19 for, will that run? First thing I'm going to see if it runs. Well, it runs with no errors. So what we're doing is we're going to say so we're going to do 1 times n, where n starts off at 0, so it'll be 1 times 0, then it'll be 1 times 1, 1 times 2, 1 times 3, 1 times 4, all the way up to 19, but not including. So let's just print that and see what happens. That's just going to give us a generator. No, it's actually given us the answer. Why? I didn't need to do a generator. Right, there is the answer, ladies and gentlemen, boys and girls, and everyone else. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's, I can't highlight this. Never mind. Let me just make that a bit bigger for you and scroll up. There we go. So the first time it runs, we've got a set going up to 18. Second time it runs. So every time, every response, every answer, or every set that it returns, it's not. It looks like a list, but from the point of view of the example, it's a set. Because we're using modulus operator, you always get a limit of that number, so you'll never hit that number. You'll only ever go up to that number -1. And if you look here, no matter what k value we put in, we always get the same. We get one of each number between 0 and 18. And that will be significant when we analyze this and progress. I've slightly taken this example out of context, so you might just be thinking, that's all very well, but so what? And yeah, I will learn about that, and we will learn about that in the next video. But for now, this is how to generate multiple sets using a prime number, using a list comprehension within a for loop. So hopefully that's I don't know. Hopefully it sparked your curiosity. Say this is not this is me learning at the same time as well. So you may want to now go ahead and read about why this is significant, or buy the book. And there it is, Programming Bitcoin: How to Program Bitcoin from Scratch. And the example, if you want to know where the, let's just look at the solution. Where's the solution? Appendix, chapter. So here we go, chapter 1. Finite fields. Here we go. So if you want to know where this is on page 252 of the book. Do you notice anything about these sets? So yeah, that's the answer that we've just got. When sorted, the results are always the same set. Yeah. Okay, so if I'd put sorted in front of that list comprehension, where do I put that? Is it yeah, so we need to put another parentheses there. Sorted, if you can spell it. And there we go, 5 identical sets because they've all got the same numbers in. No, I'm curious as to what significance this is, and I suspect so are you. So I'm going to pause, I'm going to stop this video here, and then in the next video we'll read some more, and hopefully we'll find out why this is significant. So yeah, thanks for watching. Hopefully this has been interesting. Don't confuse these videos with get rich quick, become a Bitcoin millionaire, get a job in crypto. This is learning the kind of the academic mathematics of Bitcoin, and we are using Python to help us understand. So hopefully that makes sense. See you in the next video.